Good night, CSEC scholars. Welcome to another live CSEC class. And today being Wednesday, we're doing topic by topic. And the topic that we started last Wednesday was consumer arithmetics. We're continuing with that. So last week we did simple interest, and tonight we're going to look at compound interest. So if you've always heard about compound interest and wondering what is that, and you want to find out what it is, stay tuned. We're going to talk about it and we're going to work some problems involving compound interest. Before we do that though, I would like for you to watch our schedule of classes so you know which days we have what session and what time. So here you go. See this this is glitching so bad. CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So, stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. All right, guys. So let's go. All right, so welcome Asar and welcome Imani and John. As usual, you'll be helping me. Good night. Good night. All right, so we're gonna do this together. Okay, so when we talk about compound interest, well, last week we looked at simple interest and we said that simple interest has to do with that extra money that you make when you invest. So if you have an amount of money that you're investing, that is called the principal, and you're investing it at a particular rate. The simple interest you're going to gain on that is calculated at a particular rate over a specific number of years usually. And so that's the money that you're getting from allowing an institution to have your money, right, to invest, to keep for a while. Likewise, if you borrow money from the bank, you have to give something in return for the bank lending you their money so you can have the money to go use and do whatever you want. the interest that you pay back is kind of like that extra payment you give to say, all right, thank you for lending me the money. All right, now compound interest is when you get, it's like you're getting interest on your interest, right? So when you compound an investment, you're going to get the interest for that year, and then for the next year you get the interest on the principal plus the interest from the former year. So each year the interest is calculated and added back to the starting principal for that year, which keeps getting more and more because you're adding the interest back to the principal. So at the end of each year you have a new principal which you're going to add the interest in, and it accumulates. So over time you see a huge difference between let's say an amount of money invested just at simple interest for, let's say, 5 years, or if you had invested it at compound interest, where at the end of every year that new interest is added back to it, and the rate is calculated on the principal and the new interest. So the longer the time you wait, or the longer the time you're able to invest, the more you will see the difference between the compounded interest and the simple interest. Compound interest is an exponential situation. So the more it gets, the more it gets, right? It's exponential growth. Whereas simple interest is more a linear type of growth, right? So it's just a fixed rate. You work out the interest at that rate, and that's it. So we're going to work some examples and then make comparisons. Now, I should tell you that Albert Einstein was, well, legend has it that Einstein made a declaration regarding compound interest, and he said that compound interest is one of the most powerful forces in the universe, and he called it the eighth wonder of the world. Now, I was not there when he said these words. It's legend, and I think it is worth repeating, though, just to indicate to you how powerful this thing is, right? So if you have a lump sum of money that you are able to put aside, by all means, put it aside and have it compounded. And the longer you're able to compound it, the more you're going to see the vast difference than if you had just invested that at simple interest. So let's work some examples. All right, so let's say we're going to start with, for simplicity, for the purpose of simplicity, let's use $1,000, right? So just to work with figures that are easy to manipulate, right? So let's say $1,000. So this would be our principal that we're investing for 3 years. So that's the time. And for ease again, 10%. For ease of calculation, right? 10%. So we have our principal, our time, our rate. And we know that simple interest would be principal times the rate times the time. It's over 100 because the rate comes with this factor in it, the rate over 100, right? So at the end, so the simple interest would be 1,000 times 10 times 3 and this gives 300. So $300 is the simple interest. So the amount accruing then would be the amount accruing would be the 1,000 that was invested plus the $300 interest, and that would be 1,300. All right. So let us see what would have happened if it was compounded. So at the end of each year, we add the interest and then work it again. So it will be $1,000 times the 10%. So at the end of the first year, so that would be 100. All right. So at the end of the first year, we'd have 1,000 plus 100. All right. So that's 1,100. And then we're going to find 10% of that again. So 10% of this new amount which is 1,100. All right, so that's 110, which we're going to add to the 1,100. 110. And we're going to find 10% of this again for the third year. So 10%. So that's 121. All right, so 1210, 121. And this will give 1,331. All right, so for the simple interest, we got 1,300, and for the compound interest, 1,331 for the same period at the end of the 3 years. So we can see that with compound interest, there is the difference was $31. Doesn't seem like much in, just looking at it like this, but if you had invested, let's say, are you serious? You're not so all this time I've been working and the screen wasn't sharing. Okay, so I'm just seeing oh my goodness, I'm just seeing the messages that the screen wasn't being shared. Oh, wow. So, all right. So, all I have to do is to go back. Oh, Lord. So, the thing is, when I'm on the slideshow, I can't see the messages. So, that's why occasionally I stop and go and check the chat, because I need to know what's happening. But I could swear that I was sharing the screen. All right. So, let me check and make sure. Are you seeing the screen now? Seeing it now? Welcome to those in the chat. So I'm seeing Zion, I'm seeing Jamani, I'm seeing Ngozi, I'm seeing Young DK. All right. So we're good to go now. You're seeing the screen. So what were you seeing before that? What was happening before that? What were you looking at? Anyhow, let's continue. So let me just explain then what is on the screen here. So we're making a comparison. We're making a comparison between the simple interest we're making a comparison between the simple interest and the compound interest. Give me a second, please. All right, between the simple interest and the compound interest. And so we worked it out for the simple interest. So we're investing $1,000 at 10% for 3 years. So the principal is $1,000. The time is 3 years and the rate is 10%, right? And so simple interest is principal times rate times time over 100. And we say over 100 because the rate comes with that factor in it. It's the rate is percent, so that's over 100. So the 1,000 times 10 over 100 times 3, that's $300. That's the simple interest. So the amount accruing at the end of the 3 years would be the principal, $1,000, plus the 300, which is 1,300. That's what you would get back at the end of the 3 years. Now we're going to look at what happens if we were to put it at compound interest. So we'd still work out the 10% of the $1,000 at the end of the first year. We'd get an interest of $100. We'd add that back to the $1,000. So that's 1,100. And this new figure now, we'll find 10% of that, which is 110. Add it back to that, 1,210, find 10% of that new figure. And we keep doing that year after year. So at the end of the 3 years is $1,331 instead of 1,300. And even with this small amount that you're investing for the short length of time, you can see that the compound interest will give you more money. So can you imagine if you were investing $100,000 or $1,000,000 for 10 years or 20 years? Can you imagine? So we're saying compound interest is an exponential kind of growth. It's more like multiplier or even raising to a power. It's exponential. The bigger it gets, the even more bigger it gets. And simple interest is a linear type of growth. It's a set rate. You get a fixed interest at the end of the term. Now I want to show you there's a formula, the compound interest formula, where we can use the formula to work out the amount accruing, and A would be the amount, P for principal, R for the rate, and N the number of years that you're investing it. So A, amount accruing, P, the principal that you're investing, is 1 plus the rate over 100 raised to the power of the number of years. So remember, as I told you, it's more like a power, it's exponential. And the compound interest then would be, because this would be the total amount accruing. The compound interest, the actual compound interest would be the amount minus by the principal to see the actual compound interest, right? So let's use that amount that we just did. So we had said $1,000 was invested. So that's 1,000 was the principal. We invested it at a rate of 10%. So that's 10 over 100 for 3 years. So it's raised to the power of 3. So it's 1,000 and 1. This, so 10% is 0.1. So that's 1.1 raised to the third power times 1,000, and that gives 1,331. So remember, that's what we got when we work it out step by step. 1,331. So you can just plug them into your compound interest formula to get the amount, and then the actual compound interest would be the amount accruing minus the principal, and that would give. So what I'm going to do now, so that's the actual compound interest that was earned. So I'm going to ask my scholars now to work. We're going just use a scenario to work out the simple interest. So somebody's going to work the simple interest, and somebody is going to work the compound interest using the step-by-step, year-by-year, and somebody is going to work the compound interest using the formula. So we're investing $4,000 at a rate of 5% for 4 years. All right, so who wants to work the simple interest? Who wants to work the simple interest? So somebody's going to work the simple interest, somebody's going to work the compound interest year by year, and somebody's going to work the compound interest using the formula. So who is going first? Is it Imani, John, Asar? Who wants to go first? Imani? John? Asar, nobody is volunteering? All right, I'm going to volunteer John. Ready, John? I wonder if my scholars are hearing me because nobody is responding. Oh. Okay, they got kicked out. Oh my. And okay, so you guys got kicked out. Sorry about that. Okay.
Yes, we could do 4,000 times 5 times 4 over 100.
All right. So, guys, let me apologize for all these glitches. This system has been giving me trouble from earlier today. All right. So, John, we're working the simple interest. So, you're saying what times what times what?
It's 4,000 times 5, 4 over 100.
All right. So, 4,000 times 5 times 4 all over 100.
Yes, miss.
All right. So, we know that can cancel that.
Left.
So, what we get? So 40 times. All right, so $800 is the simple interest. And what's the amount accruing? How much would you get back at
Wait,
the end?
it's, wait. 40 times 5 means 800. Oh, sorry. This is 3,200.
40 times 5 is,
800.
you sure?
Wait. Oh, no, no. Don't worry. Don't worry.
So the 800 is all right.
Yes, miss.
All right, so the amount accruing would be the principal that you invested plus the 800. And that would give, okay, so the,
4,000.
all right. So let's see how much we would get at compound interest. All right, so Asar, you go. Compound interest.
Okay, miss.
All right.
So,
So it's a
so it's
four
equals
thousand
to
dollars.
principal.
So it's a $4,000 times the 5%, right? And we're going to do this for every year for the 4 years. All right, so this one gives what?
200.
So that gives 200. And we know we must add it back to the 4,000, don't?
Yes, miss.
All right, so we add that back to the 4,000, and that gives what?
4,200.
Okay, so what's the next thing?
Then we add it back. Oh, we already did. Then we find the interest of 4,200.
All right, so we'll find 5% of that again, 5% of the new principal. So remember, compound interest, you're gaining interest on your interest. All right. Okay, so that cancel that. So what we left with here?
100.
5 2s 10, 5 4s 20 plus 1,
210.
210. And what we do now?
Then we add it back.
Add it back to the 4,002. Okay. And that gives
4,410.
4,410. What do we do next?
Then we find the the interest of 4,410.
So we find 5% of this new principal again. So 5% of that new principal. All right, so that 0 gone. 5 into 10, 2. And that's what? 2, 2. All right, add it back. So 4, 4, 1, 0. So we'd have what? 4, 6, 3. And what next, Asar?
Find the interest again.
So 5% of that new figure. All right, so you can use your calculator and tell me what this is. So 4630.5. What's 5% of that?
232.
Flat?
Yes, miss.
All right, so 4630.50 plus 232, and that
Yes,
gives what?
miss.
How much that gives?
4,862.
4,862.50,
Point.
right? 50. Am I right?
Miss, I think my calculator, it's not giving me the decimal.
Oh, so I wonder if there was a decimal. Let me check. So 5% of 4630.5. Oh, so there was decimal for this one. It rounded it off. So let me see. So that should have been, hold on. So that should have been 1.52. The rest of you check your calculators and see what you got. Start from the 5% of the 4,630. So I'm getting 4,862. Check your do your calculations and tell me if you got the same thing. Let me go back and check with you guys up to speed because all kind of madness happening. Jodian says she's hearing, but her brain is tired. She's not getting it. We're going to go over it, Jodian. But I just want my scholars to tell me if we're up to speed here. 5% of the $4,630.50. So that's $231.52. And when we add that back to the $4,630.50, we get $4,862.02. That's what I'm getting. Are you guys hearing me?
Yes, miss.
Because I feel
Yes,
like
miss.
I get the feeling like I'm out in the wilderness talking to myself. All right, Imani, let's work it with the compound interest formula and see if we get the same thing. So the compound interest formula, the amount would be the principal times 1 plus the rate over 100 raised to the power of the number of years. So plug in what you need to plug in now and tell me what we have. So the amount will be what?
Miss, the amount of 4,000. Wait, I forgot the figure.
So the 4,000 was invested as a principal, right?
Yes.
One plus, and the rate was 5%.
Yes, miss.
And the
Okay.
time was 4 years, right?
Yes, miss.
So raised to the power of 4. So how much that give you?
Okay, so 4 times 1.04. So 1.05 to the fourth power is 5. Miss, that's 1.215
Times 4,000.
times 4,000 is 4,862.025. So it's probably what you got.
Okay, right. So we get the same thing. See? And the actual compound interest now would be this money, the amount, minus the principal, the 4,000. And that is $862.
862.02.
So what was the compound interest for the last one? The simple interest, sorry. The simple interest was $800, right? If we invested it at simple interest, we would have gained $800 extra on it. When we invest it at compound interest, we gain $862.02 after just 4 years. As stated before, you begin to see the real magic. A lot of persons refer to it as magic. And as I said, legend has it, Albert Einstein called this the eighth wonder of the world and one of the most powerful forces in the universe. To invest money and for it to grow exponentially. The longer you leave it there, the more it's going to. So it's like it's picking up speed each time. It's it's picking up speed, and that's why Einstein was referring to it as a force. Because when we think of falling objects, they fall faster each every second they fall faster. So they're picking up speed each time. So it's the same thing with the compound interest. After just 4 years, there's a difference of $62. So imagine, and this is just investing $4,000. Imagine you take $40,000, $400,000, $4 million, and invest it for 10 years, 20 years, 30 years. Work it out in your own time, work it out, and see the difference that you would make compared to if you had just invested it at simple interest for that period of time. Even taking into consideration factors like the cost of living, you know, certain fees you have to pay to keep it there, that kind of thing. Even taking those things into consideration, the difference is vast. For those who are not getting it, I'm going to go back over this one. So we had said we invested $4,000 at 5% for 4 years at simple interest. And the simple interest formula is simple. It's simplest. The principal times the rate times the time over 100 because the rate is over 100. So the $4,000 is the principal. That's the amount that was invested. The rate is 5 over 100, 5%. The time was 4 years. So it's just one fixed interest. You work that out, $800 is the interest. You add that back to the principal to get the amount accruing after the period. 4,800. At compound interest, so there are two ways you can work compound interest. You can do it year by year by year, which is very tedious if it's many years. Suppose it was 20 years, would you keep working out the simple interest, add it back, work it out again, add it back, work it out, add it back for 20 times? So it's a good thing we have an actual formula we can use. But all right, just for the sake of demonstration, we say, okay, let's work it out year by year by year. So we work out the first year, we found the 5% of the money. We got $200, add it to the money. The new principal is 4,002. We're going to put that back into the chamber. Find 5% of that again, which is 210. Add it back to that principal. Find 5% of that new amount. Add it back. Find 5% of that new amount and add it. 4 times we did it, 4 years. So this is the amount you get back. This is the amount you get back at the end of the period. There's a difference of $62.02 compared to the simple interest. And using the formula now, we just plug in the values into the simple interest formula. The amount accruing is the principal times 1 plus the rate raised to the power of the number of years. So we just plug in the values. 4,000 for the principal, 5 for the rate, 4 for the number of years, and we get our money. So this is the amount accruing. The actual interest would be to subtract the principal that was invested. So the actual compound interest is $862. $62.02 more after 4 years. All right, so give me some feedback. Let me see what's happening in the chat so far. Oh my. Okay, so let me apologize for the glitches this evening. Sometimes the systems just don't work properly. So we're going to go do another run. Let's try some bigger numbers this time and some bigger time period so we can see the difference it makes. So we're not going to do the year by year by year by year by year. For this one, we're just going to do 2 examples, and we're just going to work the simple interest and work out the compound interest using the formula. All right. Or maybe we can do three examples quickly. So use your calculators and let's get it done quickly. All right, so Imani, so we're investing 80,000 at 20% for 15 years. Work out the simple interest and work out the compound interest for me.
Okay, miss. So the simple interest is principal times rate times time over. Well, principal times rate times time. So,
So that would give
so 80,000 times 20 over 100 times 15. So
80,000 times 20 over 100 times 15 And that would give,
Um, and so for the
no, work it on your calculator and tell me.
S 240,000.
200, 240,000. This gives,
Wait, wait, wait. Oh wait, I put in the wrong number. Times 15 times 20. Miss, getting the same over and over. I'll just work it.
240,000.
Yes, miss.
All right, so let's see if that's what we get for it. So 240,000, and that's just the interest. And so we'd add that back to the 80,000.
Yes,
So the total amount at the end of the period would be,
this would be 320,000.
all right. Um, okay. So what would be the compound interest? So the amount will be what?
So, oh, miss, we're going to write the formula.
Just plug them in the interest of space. All right, let me put the formula here. So that's A equals P 1 plus R over 100 to the power of N. All right, so P would be what?
P would be the 80,000,
So 80,000.
and then 1 plus
So that's 1.2.
yeah, 1 point. Oh, okay. So, to the power of 15.
All right,
So,
work that in your calculator.
okay, miss, 80,000. So,
Work out the power first. You know that, right?
yes, yes, miss.
Yeah.
So, power of 15 times 80. Miss, that would be 1,232,561. 561.726.
So that would be the
726.
amount.
Yes, miss.
That's a vast difference, isn't it?
Yes, miss.
That's a vast difference. All right, so this is the amount. So the compound interest would be to subtract the 80,000 from that. So take away 80,000 from that.
Okay, miss. So, minus 80,000. 1,152,561.
Hold
So,
on.
oh, yeah.
All right, so that is 1,562,000.
Yes, miss.
And how
1
much?
million one. Wait, miss. Wait, miss. $1,152,561.
What did I do? All right, so 1,162,000.
152,561.
Point
0.726.
0.72. All right, that's a great, mighty difference. Mighty difference. Because it was a much, much larger amount, much larger rate, 20%, which is rare that you're going to get any kind of investment like that. But just to demonstrate the difference, and 15 years. All right, Asar, so your turn. All right, so let's
Okay,
say,
miss.
all right, so let's say $12,000, 7 years, and 8%. Work out the simple interest and the compound interest.
The simple interest is equal to 12,000 times 7 times 8 over 100.
And that gives what?
6,720.
6,720. And the amount would be that plus the 12,000. How much is that?
$18,720.
All right, so this is the amount you would end up with at the end of the term, and work the compound interest now. So the amount for the compound
So
interest would be
12,000 bracket
times,
1
so the 8% is 0.08.
plus.
So it's 1.08. 1 plus the 8% is 1.08, right? You follow that?
Yes,
So we
miss.
just, okay, and we're raising it to what power?
To the power of 7.
All right, so tell me how much that is.
1.714.
All right, so that's 1 point.
714.
Okay, I multiply it by the 12,000.
20,565.89.
Okay, so tell me that figure again. 20,000.
20,565.89.
All right, so this is the amount. So it's 20,565.89 compared to 18,720. And the actual compound interest would be that amount minus the 12,000. So how much is that?
$8,565.89.
All right, compared to the $6,720, right?
Yes, miss.
Okay. So we can see, it's demonstrated, we have shown the difference. Compound interest definitely gives you a good run for your money. All right, John, your time. So let's um take it down back a notch. Take it down back a notch. So $600, because we don't want to feel that only rich people can invest, right? If you have a little $600, you can invest it. So let's say $600, right? 15%. And you say, all right, you're going to make it stay there for 30 years, though. 30 years. 30 years. So what would be, so work out the simple interest for me.
Okay, that's 600 times 15 over 300. Oh, 13. Oh, 600 times 15 times 30 over 100.
So 600 times 15 times 30 over 100. And this gives what?
Okay, 6 times 30 is 180 and 180. 15. That's $2,100.
So that's more than 4 times what you invested in. Because it's so long, because it's 30 years, the interest alone is more than 4 times the principal. So the amount that you would get back at the end of the 30 years would be the 2,700
Plus the 600.
plus the 600.
That's like 3,300.
Right. So because the time is so long, you see how much you get back?
Yes. That's also money.
Right. Yeah.
Right. Yes.
3,300.
Now
All
work
right.
on the
So
loan.
okay. So work it at compound interest now. And let's see.
Compound interest.
So for the compound interest, let's work the amount. So it will be what? The principal.
With 600.
So the 600
Times
1.15. The 0.15 is 15%. And is 1 plus the percent, right? So we're raising it to what power?
to the 30.
To the power of 30.
Yes.
All right, plug that into your calculator and tell me how much you get.
It's 39,727.06.
So 39,700
$27.06.
$727.06 compared to 3,300. 39,000 instead. The actual compound interest would be to subtract the amount, subtract the principal. So you see the difference that 30 years makes. You put $600 aside for 30 years. And you see how much extra money you earn. Mark you. So we're saying you have to take into consideration inflation, right? Inflation, cost of living, rising prices, blah blah blah. But still, to invest $600 and get back $39,000, that's a nice little situation, isn't it?
Yes, miss.
Yeah, that's a nice little situation. So do you understand then the difference it makes when you're investing at compound interest as opposed to simple interest? Do you think you can appreciate the difference?
Yes, miss. It's because in the compound interest, you get more money than the simple interest.
Yeah, and the longer you invest it, the more you can see. As we say, it's exponential growth as compared to a linear growth, right? The longer you invest it, the more you're gonna see turnover. So if it's just a 1 year, a 2 year, 3 year, 5 year, you will see a difference, but it's not going to be so striking to you as when it gets into the 15 years, 30 years, 100 years. You must try it on your own and see. In work out if you were to invest something for 100 years at compound interest. Let's say you just tell yourself, it's not for me, it's for my grandkids or my great grandkids, right? Let's say you just tell yourself, here what? I know I'm not gonna benefit from this. I'm more than likely will not be around in 100 years. But I want my great grandkids, I want to leave something for them. And you take the money and you invest it for 100 years, work out at compound interest what it would be and compare that to what it would be if you had just invested it at regular simple interest. All right, so that's our class for tonight. That's the wrap. Hopefully you understand clearer now. And for those who are just meeting compound interest for the first time, I hope it is clear to you. If not, feel free to watch this video again and again and again and again and again until you are satisfied that you have mastered the concept. So, scholars, thank you for sharing your time with me and thank you for participating. Those in the chat, likewise, we appreciate your company. We appreciate your answers, your comments, your questions. And I'll see you guys tomorrow. Bye, Asar. All right, so here's our schedule of classes. Remember, we have 5 live PEP classes per week and 6 live CSEC classes per week, including our midnight oil multiple choice, CSEC multiple choice paper 1 class. That's on Thursday at midnight. So don't miss that one. Hello CSEC math students, I know you are busy preparing for your math test and your CSEC exams coming up, I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.